Good morning, everyone. Just first want to say I miss you guys all. Yesterday it was awesome to be able to talk to some of you guys through email and things, um, and just to hear from you guys and know how you're doing. So uh, we're going to be moving on today from to our next form of energy. Last week we focused on chemical energy, and this week we're going to move on to the next form, which is heat or thermal energy. Okay, so please get your notes out. If you've been taking notes on your document or your notebook, please have those out. I'm going to do a short video today, and then I'll do a short video on Thursday too. And after each, there'll be a little something that you can be working on then. Okay, so for today, we're going to start with, of course, a little warm up like we used to. But I want you just to, in your notes, take a guess, a hypothesis of what you think heat is. Okay, using, of course, Bill Nye the Science Guy. So pause this video, take 2 minutes, it's a minute 45, to just simply watch this video. It's a good introduction to what heat is. All right. Now that you've watched that, okay, I want you to look at, this is our target. This is our goal for this whole heat energy lesson here. It's explain the effects of the transfer of heat that occur between objects at different temperatures. So this is a good time to remind you that energy, remember, does not get created or stored. So when you have something that is heated up or hot, or something that is cold, that's not going to go away. That energy that it has is going to go away. It's going to transfer. And so what we're going to be looking at for thermal energy or heat transfer is we're going to look at how does it do that. Okay, how does heat go from one thing to another? Okay, so in order to do that, we're going to do the first thing that I want you to officially write down as far as the notes go, and that is thermal or heat energy. Okay, if you want to put heat in parentheses, that would definitely help you. What is thermal energy? Thermal energy is the energy of moving particles that make up all of matter. Okay, and on the next slide, I'll show you some pictures of what that moving looks like. Okay, and so as chemical was a potential energy, when we burned the food and everything, that all had a potential energy. It wasn't moving. Thermal energy is going to be the opposite. It's going to be a kinetic energy. It is going to be moving. It's the moving particles. Okay. Now, as you may know, we feel thermal energy as heat. That's what we call heat. Okay. If something is hot or it's be careful, it's going to burn you. It's hot. That is what we are feeling as thermal energy. Okay. Now, the key thing, the thing that always just kind of makes me a little bit shocked or reminds me of things that I think are the way they are, but they're actually different, is this sentence right here. And this is very important for you to put down. Heat always goes from warmer objects to a cooler object. Okay, so heat always goes from the hotter to the cooler. Okay, even if two things are extremely hot, the one that is the hottest temperature is going to transfer the heat to the other one. Okay, but that's probably easiest. I know in school I usually do this demonstration, and I have students, if they feel comfortable, just grab somebody, like high five somebody, or touch somebody else's hand. And I know that is uncomfortable for some people, but right now I want you to just find something around you that you think is cooler. Okay, so most likely your two hands together are going to be a similar temperature, but you never know. So maybe you had it one hand outside of a blanket or something like that, where it's going to be cooler. But so for instance, for me, I'm going to here's an outside window. Okay, and I'm going to come over here, and I just want you to put your hand on it. And this outside window is definitely cooler than what my hand is. Okay, and so the thing that gets me every time is, us being in Wisconsin in the winter, whenever we feel cold, okay, if I grab onto my car handle when I'm getting ready to get in the car for school, it feels cold. But what is actually happening is the heat from my hand is being transferred to that object, okay? So, for instance, my hand touching the window, okay, my hand was hot. It was the warmer temperature. So my heat was being transferred to the window. Okay, I don't know why that's always just shocking to me, because I always feel like the cold is hitting me, but that's not the case. Okay, so if you go and touch something right now, you have to have the understanding that your heat is being transferred away. Okay. And so if you think about the many different things that you encounter, if you're just trying to warm something up or somebody up, your heat's actually transferring to them. Okay. So it's not the fact that they're cold, that they're going to make you cold. Okay. Really what they're doing is they're taking away the heat from you, and then that makes you cold. Okay, so important point, and I'll go through that with some examples and things too. But that make sure you have these two things written down. These are going to be the two main things that you need to know for this lesson. Okay, the next thing that I want to talk about is that there's three different ways that heat transfers. Okay, and I want you to space these out in your notes. We're only going to go through one today, and the other two on Thursday. And so the three things are conductivity, or conduction, convection, and radiation. So again, space these out in your notes. Okay, conduction at the top, leave a few lines, and then have convection and radiation. There'll be a few things we talk about for each of these. Okay, and I want you to take a look over on the right after you have those written down, and look at this graphic. Okay, it says all particles in a solid vibrate, even when they are cold. Okay, so you have the particles in something, and they're vibrating. Okay, now when they do that, if they are colder, notice that how they vibrate is going to be shorter, okay, and slower. When things are at a higher temperature, okay, they vibrate faster and then they take up more space. So if you think of things like food that you're trying to preserve, so you keep it cold so that those particles don't move as much and they're closer. When you heat something up, when you're boiling water, okay, you freeze water, it's gonna, it's gonna be cold and small particles, and then when you heat it up, it's gonna go crazy and move fast. Okay, that's the moving or the kinetic energy part of heat. Okay, so the only thing we're gonna take notes on today, as far as the three ways that a heat transfers, is conduction. So this is what I need you to write down. Okay, it is a kinetic energy because it's moving, but for conduction, I want you to put down conduction is the transfer of heat between two things, or substances you can say, that are in direct contact with each other. Okay, so for example, when we touch the window, you touch whatever it was that you feel cooler. The example that's here on the slide, if you touch a hot pan, okay, if it's a direct contact and you feel heat, that is going to be conduction. Okay, so whenever you touch something that is warmer or cooler than you, there is heat being transferred using conduction. And it's whatever is warmer, the heat is going to then be transferred. So for a pot, okay, I'm sure most of us have accidentally burned ourselves with some sort of cooking material, right? A pan or a pot of some sort. And when you touch that pan, what's really happening is that the heat from the pan, that is obviously warmer than what your hand is being transferred from that to you. Okay, and that's how you get burnt. Okay. So how are we going to show you this? I have a little lab or experiment that you do. Okay, it will not take long, and it's very simple. You can use all the materials from your house to do this. Do not go out and get anything by any means. Okay, but we're going to be looking at, we have these plates that we would have done a demonstration with in school if we were in class. And these two plates, these two black plates, are actually made of different material. Okay, and so if you look at this list of materials that I have here, okay, everything from copper to air to wood to plastics, okay, everything has a different thermal conductivity, or ability to conduct heat if it's in direct contact with it. Okay, and so what you're going to be doing is this lab. Okay, so I'm going to post this and give you guys your own copy of this. And there's not much to do. There's the vocabulary here that we just talked about, the materials that you need, 2 ice cubes of roughly the same mass, 2 different materials to set the cubes on. Okay, well, I'll go over with some of the examples that I have. And then some sort of a timer clock. It could be on your phone or anything where you can just keep track of time. And basically what you're going to be doing is you're going to be getting a couple different materials and putting the ice cubes onto the materials to see which material conducts or transfers the heat quicker. Okay, and so you're going to make this hypothesis and observation here that says, I believe that blank material will melt the ice quicker than whatever your other material or materials. You can do more than just two if you are feeling very motivated to do so. Okay, I think this is really interesting, and we've done this before and tried some things, and we were shocked by how some materials conduct the heat compared to others. And then so you're just going to make an observation. Now, in here, you're not going to be doing data like numbers or anything. You're just going to be making a simple observation. Which one is melting more? Which one seems to be melting faster? Is there a big puddle for one? Is there not a big puddle? So in here is just a short description, not a full sentence or anything either. Just a short description like not melting at all or melting, significantly faster. Okay. Please make sure though that when you're doing this, have it all be in the same spot. Okay. You don't want to have one outside, especially if it's like raining today. Okay. That's going to affect your lab, your experiment. Or don't do one in the fridge because that's obviously going to melt slower and change it. But you want them to be in the same spot. Room temperature is fine. Or if you find a sunny spot sometime today and want to put them both in the sun, something like that's fine. But make sure that they are equal. Okay, that we have that as a consistent, constant variable. And then there's just a little analysis, which one did it show? And then there's a couple videos, including a video of this little demonstration that we would have showed you today and how this works. Okay, and it's pretty actually shocking to see how quickly those go. So I won't, ruin that one for you guys, but go ahead and watch that video and then just explain why you think that might be. And then finally, there's above and beyond if you have more time and want to learn more about thermal energy that is there. Okay, so to kind of sum up the lab and what you're going to be doing, all you need to do is get some different materials. So I picked out just 3 things that I just found around my house. So I got a plastic container lid here, okay? And, and all you're going to be doing is setting them in a room temperature kind of area or someplace that you want to. I got a wood cutting board. Okay, and then I just found a cookie sheet pan. And so all I would need to do is go get some ice cubes from my ice cube tray. I'd put one on each, and then I'd make some observations. Now, if you're finding that after the time, a minute, 2 minutes, and 3 minutes to 4 minutes isn't enough, you can adjust these times for what you want. If you want to do it every 5 minutes, if you have time, and then just come back and check, that works fine too. Okay, we just have it for 4 minutes because that's what we have used in the past, but we're using different materials at school, so that it might change a little bit, and you might want to extend it depending if you have in the heat or room temperature or if it's a little cooler in your house. Okay, so I hope you have fun with this. Put some ice cubes on, try to figure out, but the thing that I want you to remember, okay, is that when you're putting things on, like say I put an ice cube on here, okay, what do you think is going to be warmer? The ice cube or the pan? Okay, I'd like to think you would say the pan, right? The pan is warmer. So where's the heat being transferred? Is the cold from the ice cube hitting the pan, or is the pan's warmth or heat going to the ice cube, which makes it melt? Okay, continue to be thinking about that. If you have to go back and watch some of the video to try to answer that question, please do. But it's a really interesting topic and form of energy that is a different way than what you typically think of. All right, thank you all for watching. Please make sure to take your time, take notes. I miss you all, and see you Thursday for the next video. Take care.